Okay, so let's just take a minute and talk about what the instructions will look like for whenever you see constructing a confidence interval. All right, there are two things that the directions will look like for when you're constructing a confidence interval. One of them will usually state construct and interpret a 95% confidence interval for blank, or just construct a confidence interval. Now, when you see those directions, you have to understand exactly what they're asking you to do. It's literally not just putting down a confidence interval, because if you just put down the confidence interval, then you're going to be incorrect. All right. So what do these directions actually mean? You must know that when it says to construct or construct and interpret a confidence interval, you have to do the state, plan, do, conclude method outlined on the previous slides. We're going to go over what this looks like, but don't just construct a confidence interval, throw your work down, and expect to earn credit. You're going to have to state, make sure that you state what the assumptions are, state the name of the test, show your conditions, simple random sample, approximately normal, and independence, show the numbers plugged into the confidence interval, and then interpret the confidence interval in context. Okay, so next question is, what exactly is on the formula sheet? Remember that we said the specific formula for each individual confidence interval is not going to be on the formula sheet. However, you have this general confidence interval formula on the formula sheet for the AP exam. You just have to plug in what you know. Statistic, we know for proportions, it's p hat. Critical value, you're going to use z-scores. Standard deviation of the statistic, boom, that is on your formula sheet right here, as long as you know you're talking about proportions, and just know that this is going to be p hat. Since we don't know the population proportion, we're using the sample to estimate it. All right, so why exactly is this called a one sample z interval for p? Okay, one sample, we're constructing our confidence using a proportion from one sample of the data that you've collected. All right, so if we were talking about the bead example from the very first slide, where we were estimating the proportion of red beads in the cup, you would take one of those samples, find the proportion of red beads from that one sample, okay, and construct your confidence interval using that one sample. It's a z interval because you're using the standard normal curve to find the area, and with the standard normal curve we use z-scores. That's a standardized score for your z-scores. And then for p, that comes from that saying we are using our point estimate to estimate a proportion. So we're checking to see if our confidence interval captures the true proportion. So 4p just means it's z confidence interval for proportions. We're estimating a population proportion. All right, so let's just take a look at a couple of examples. So students in AP statistics wanted to estimate the proportion of pennies in circulation that are more than 10 years old. To do this, they gathered all the pennies they had in their pockets and purses. Now, this is a sample because there's no way to collect all of the pennies, in the whole United States and see what percentage or proportion is more than 10 years old. So when they did this, 57 of the 102 pennies they had were more than 10 years old. Notice the instructions: construct and interpret a 99% confidence interval for the parameter. Is it possible that more than 60% of all pennies in circulation are more than 10 years old? So let's think back to those set of directions to understand what construct and interpret means. This means that you're going to have to do that whole 4-step process to earn full credit, and you're going to have to use that specific interpretation. We are 99% confident that the interval from blank to blank contains, okay, we'll be going over that, but just so you know that that's exactly what that means. All right, so here's what the state portion looks like. You're basically stating what you're doing here, and you're giving the name of the test. What do we want to do? We want to estimate P, the true proportion of pennies in circulation that are more than 10 years old. Okay, and just think about this as handing this to somebody and they would be able to read it and completely understand what you're doing. And we are using a one sample z interval for P. You can say confidence interval if you want to, 4p, to estimate the population proportion. Now the plan is going to be checking your conditions. Since we're using z-scores, you have to check, and since we're using the normal curve, you have to check these three conditions. Simple random sample of 102 pennies, notice that's in context. It's approximately normal. Now where'd the 0.56 come from? That came from the proportion 57 out of 102. So 0.56 times 102 is 57. 0.44, which is 1 minus p, times 102, which is 44.0. Both those are greater than 10. I can use the normal curve. And it's reasonable to assume that there's more than, notice how I show the numbers plugged in, 10 times 102 or 1,002 pennies in circulation. Therefore, the sample is independent. Okay, and that's allows us to use the standard deviation. So now we're just plugging our numbers in. So 0.56, okay, and some of you might be asking where the 0.56 come from. The 0.56 came from taking 57 divided by 102. That's the sample proportion. I should have put that on here. All right, so that's where that 56 came from. The 2.5758, we're doing a 99% confidence interval. So remember, if we're doing a 99% confidence interval, then if you need to draw your curve, okay, we know that we want to capture it 99% of the time. And then over here, this is going to be 0.05% of the time and 0.05. So you're going to do inverse norm of 0.05 or 0.995 because that's the area to the left of both of your critical z-scores. Okay, so you choose whatever works best for you. Okay, that gives you 2.5758. Notice my standard deviation is literally my sample proportion, 0.56, 0.44 divided by 102, square root of 102, take the square root, and notice how I give the final answer for the confidence interval from lowest to highest. Okay, oh sorry, here's your p hat, came from 57 over 102, critical z-score, inverse norm 0.995. All right, and then notice the conclusion. So the interval is you're 99% confident that the interval contains the true proportion of pennies in circulation that are more than 10 years old. Notice that I'm using the word true proportion and then in context. The level is the method. If we were to take many, many samples of size 102, 99% of the resulting intervals would capture the true proportion of pennies in circulation that are older than 10 years old. Now, this question says, is it possible that more than 60% of all pennies in circulation are more than 10 years old? So this right here, this confidence interval, is estimating the proportion of pennies that are more than 10 years old. So this says that the true proportion of pennies that are in the circulation that are more than 10 years old is potentially lies in the interval from 0.43 or 43% to 69%. So since 60% lies in that interval, that could be one of the true population proportions. All right, so let's take a look at another example. I'd like you to try this one on your own after seeing the last example before I go over it. So in our first grade social studies class, Jordan learned that 70% of the Earth's surface was covered in water. She'd wondered if this was really true and asked her dad for help. To investigate, he tossed an inflatable globe to her 50 times, being careful to spin the globe each time. When she caught it, he recorded where her index finger was pointing. In 50 of her tosses, her finger was pointing to the water 33 times. Construct and interpret a 95% confidence interval for the proportion of the Earth's surface that's covered in water. And is this consistent with the claim? Okay, so what you're going to do is just make sure you do that state, plan, do, conclude. So try it on your own, hit pause, and then check your answer. All right, so let's see how you did. All right, so you should have had your state portion. Remember, this is basically just telling the readers what exactly you're doing, and you're kind of restating the question and what you're estimating. We're estimating the true proportion of the Earth's surface that's covered in water with 95% confidence. Also notice you have the word true proportion in context and what confidence level, and then what you're going to use to do this. One sample, it's a one sample with 50 tries, Z interval because I'm using the standard normal curve, for P, population proportion, if the conditions are met. Simple random sample of 50 locations around the globe in context. 10%, we don't really need to check the 10% condition here, so this is a little bit tricky. The locations are not selected without replacement, so therefore the sample is independent. So it is done with replacement because every single solitary time you throw that globe up in the air, your finger could land on the same spot 50 times. That's okay, because every time you toss the globe, it's going to be different. Approximately normal, you've showed your plugins, okay, 50 times 0.66, 50 times 0.34, and if you're wondering where that 0.66 came from, just remember that's from the original question of 33 over 50, so you actually have to find that proportion, and both of those are greater than 10. Make sure that you're stating independent and approximately normal. Point estimate was 0.66. 1.96 is your critical z-score for 95% confidence interval. I'm actually thinking that you'll pretty soon just have that memorized. 0.66 times 1 minus 0.66, notice this is your p hat, divided by the sample size, take the square root. Okay, this whole thing is your margin of error. Remember, this is your standard error because it's the standard deviation of the statistic. And here's your confidence interval. All right, so let's take a look at the interpretation, the conclusion. This is what you will always need to include every single solitary time is the interval. So we're 95% confident that the interval from 0.529 to 0.791 captures the true proportion, notice the word true proportion, of the Earth's surface that's covered in water. Now, the level you don't have to interpret unless the question asks you to. So if we were to take 100 samples, 50 of the resulting confidence intervals would capture the true proportion of the Earth's surface that's covered in 95 of the 100 samples. And then to check whether or not it's consistent, so remember the goal of creating a confidence interval is to capture the true proportion. So anywhere between those two numbers, the true proportion could lie. Okay, now like I said, don't state the word between here because it's not always between these two numbers. It could be, different intervals are going to give you different answers, so that between changes every time, so just avoid that word. Now, if you look, so based on our experiment, 52% to 79% of the true proportion of the Earth's surface is covered in water. The true proportion could lie somewhere in that interval. So since the claim is 70%, that's somewhere in that interval, it is possible that it does support the claim that 70% of the Earth's surface is covered in water. All right, now you can use your calculator to find a confidence interval. So go ahead and go to Blackboard. Under the calculator folder, there's a video tutorial on how to construct a confidence interval. Now, you are more than welcome to use a calculator to do this. However, you still are going to have to show these plugins. I personally use a calculator every single time. I just show these plugins right here. You don't even have to show this step, but you do have to show the initial plugin for that first step. So how can you do this on your calculator? And this actually just is kind of helpful because then you don't, you're not sort of messing up any of the calculations. All right, so you're going to press the stat button, which is down here. You can't really see it. Okay, and then when you press the stat button, scroll over to tests. All right, now these are all the tests we're going to be using, so get used to this button. Scroll down to where it says 1 proportion Z interval. So that's actually helpful in knowing the name of this test, 1 sample, Z interval, 4 proportions. Now notice what comes up next. X is your number of successes, N, or once you hit enter, N is your number of trials, confidence level 95, you highlight calculate and press enter. Oh, boom, here comes my confidence interval right up. Notice how it gives you your p-hat value, 0.66, okay, and gives you the confidence interval answer. Okay, but like I said, you just cannot just give this confidence interval answer. You have to show the plugins, and if your plugins are incorrect on your work, then you only get partial credit. So just be careful with that. Okay, so I guess I kind of answered this question. Why did you show all that work when the calculator will do it for me? Because students get the correct answer with the calculator, but they show incorrect work with the formula. So if you will lose credit because it's considered 2 attempts at the problem, if you have the correct answer but incorrect work, that's saying like, oh, I'm not really sure which one is right, the answer that I got from the calculator or the one that I wrote down. Calculator speak is not showing work on your homework tests or AP exams. So because every calculator does stuff differently, therefore you can't use calculator speak because not everybody speaks your calculator's language. All right, you're going to plug your numbers into the formula. Just make sure they're correct, then let the calculator do the work for you. So much easier. I would avoid using symbols, and I would just go straight into plugging the numbers into that confidence interval formula. Often students will use the wrong formulas and you lose credit. So they'll put P's in instead of P-hats in instead of P, so just plug the number straight in. You don't actually have to show the formula. Where's the best place to use the calculator on the AP exam? Definitely on the multiple choice section. Honestly, all that work that we showed in the previous slides for the multiple choice section, you're not going to have to show any of that work. So go for it. Get used to using the calculator so when they ask you a confidence interval question, boom, you plug it in and you're done, and it saves you a lot of time. Okay, so the next thing we're going to take a look at is choosing the sample size given a specific margin of error. So when you're planning a study, we may want to choose a sample size that allows us to estimate a population proportion within a specific margin of error. Remember that the margin of error formula is the entire z-score times your standard error, and your z-score is your critical value for the level of confidence that you want. So that whole thing is your confidence level. That whole thing is your margin of error. Because the margin of error involves using the sample proportion p-hat, we guess the latter value when choosing n. There are two ways to do this. We're going to use a guess for p hat based on a past experience or pilot study, or we're going to use p hat as 0.5 as the guess.